In our first problem, we want to take the letters to the left, so I'm going to subtract 3v from the right. We want to take the numbers to the right, so I'm going to add 1 to each side. These will go away. 6v minus 3v leaves me with 3v. 14 plus 1 leaves me with 15. If then I divide by the 3 that's in front of the v, I get my final answer of v equals 5. Problem 2, same general idea. Last time I didn't do it the negative way. I decided to take the letters to the right. This time I'm going to show you what happens if we go negative. So I'm going to move this 8w over here. I'm going to move this 25 over here. These go away. These go away. 2w minus 8w is negative 6w. 1 minus 25 is negative 24. If I divide by what's in front of the w, negative 6, that's how I get my answer of w equals 4. Again, I get to the same answer if I instead subtracted 2w from each side and subtracted 1 from each side. The difference would be I wouldn't have to divide by a negative, and I'd get right to that positive answer of 4. That said, sometimes it's easier for people just to think in terms of, let me move the letters to the left, let me move the numbers to the right. And I'm trying to show you that that will still work every time. You just might have to deal with some negatives. In problem 3, we already have the like terms on the same side of the equation. So here, this understood 1x plus 3 more x's gives me a total of 4x. This negative 6 and then negative 14 more gives me a total of negative 20. If I divide by what's in front of the x, 4, that's how I get x equals negative 5. Problem number 4, 7x minus 11x leaves me with negative 4x. Negative 17 plus 1 leaves me with negative 16. So when I divide by what's in front of that x, a negative 4, I get x equals negative 16 over negative 4, which is a positive 4. In problem number 5, I got to get rid of this 2/7 by subtracting it. When I subtract 2/7 from 5/7, I have a common denominator, so I can just do top minus top, 5 minus 2 to get 3, and leave it over that common denominator of 7. So I'm just left with x equals 3 over 7. In problem number 6, I'm going to move this 1/9 to the other side by adding 1/9. Again, this is a case where I do have a common denominator, so all I need to do is combine the tops. 1 plus 7 gives me 8, still over that common denominator of 9. In problem number 7, we're multiplying by 6. In order to undo multiplication, I need to divide, or really I could see this as 6 over 1 times y. So to undo it, I would multiply by 1 over 6. That way this becomes 6 over 6 or 1, and just leaves me with a single y. To do it, I multiplied by 1 over 6 on the left, so I also have to multiply by 1 over 6 on the right. This just leaves me with y. Here, top times top, 1 times 1 gives me 1. Bottom times bottom, 2 times 6 gives me 12. In problem number 8, since I have 2/3 on the left-hand side, I'm going to multiply by its reciprocal, 3 over 2. When I multiply by 3 over 2 here, these will go away and just leave me with x. I could multiply this out and get negative 18 over 50, but you're better off saying, well, wait, I know that 2 goes into this and this. 2 goes into 2 once, 2 goes into negative 6, negative 3 times. That way it's going to become negative 3 times 3 equals negative 9 over 25 times 1 equals 25. I'd want to check and say, does anything go into both 25 and 9? It doesn't. That's why I can leave this as negative 9 over 25 as my final answer. Problem number 9, I'm going to multiply by negative 5 over 4. That way I'll just get 1x. When I multiply this by negative 5 over 4, I get 1 times negative 5 is negative 5, 10 times 4 is 40, so it could become negative 5 over 40 that would reduce to negative 1/8. But it'd be better if I recognize, well, wait, 5 goes into both of these numbers. It goes into 5 once, it goes into 10 twice. Then I would get 1 times negative 1 is negative 1, 2 times 4 is 8. So I'd arrive at that same answer of negative 1/8, but I'd get there quicker if I could see that those 5's reduced. Last problem here, I'm going to add 7/10 to both sides. When I go to combine the right-hand side, I realize this is not the common denominator, so I need to think what's the common denominator between 10 and 20. The common denominator would be 20. If I multiply the second fraction by 2 over 2, that'll get me there. This becomes 1 over 20 plus 14 over 20, which gives me a total of 15 over 20. But I can't write my answer as 15 over 20 because there's a common factor that goes into both of them. Specifically, 5 goes into 15 3 times, and 5 goes into 20 4 times. So my final answer should really be x equals 3/4.